Let's find the Thevenin equivalent circuit for everything external to A and B right here. Okay, so let's just say we want to reduce everything outside of that to our Thevenin equivalent circuit. So we're going to remove the 3 ohm resistor from our circuit and then work through our steps. So step 1 is to find our Thevenin, and of course we remove the sources to do that. So at the same time I'm getting rid of that 3 ohm resistor, I'm going to go ahead and draw the circuit I'm going to need. Actually, I'm just going to put the voltage source in here for a second and then we're going to remove it. So A is over here. All right, so when we go to find our Thevenin, we have to remove our sources. So again, if we have a voltage source equal to 0, that's a short circuit. If we have a current source set to 0, that's an open circuit. So in this case, we're removing a voltage source. Wow, that took a lot of my circuit, didn't it? So we're just going to short that out. And what happens when we do that? Now, again, this is where it really comes in handy to understand that we're looking right here at these terminals, A and B. So if I put my ohm meter here, right at A and B, and remember, it's going to put a little bit of current into the circuit and expect that current to come back. So some of the current will go this way and some this way. And of course this current will just meet back up. Over here, notice when the current gets here, none of it's going to continue on through the 2 ohm resistor, because since we shorted the voltage source, that actually shorted the 2 ohm resistor. And so this is basically what we have. So if we're measuring our resistance here, notice that the 4 ohm and the 6 ohm resistor are actually in parallel. So our R Thevenin is 1 over 1/6 plus 1 over 1/4. Wait a minute, I don't think that's 2. I think that's oh, 2.4. Sorry about that. 2.4 ohms. And now we want to find our E Thevenin. So we put our our voltage source back into the circuit. Put sources back. Find the open circuit voltage at A to B. Okay, so I'm just going to redraw again. 6, 4, there's that 8-volt source, 2 ohm resistor out here. And here were our terminals A and B. Again, don't lose those. Those are really important in finding our Thevenin equivalent circuit. So again, basically we're putting a voltage source right here, a voltage meter, a voltmeter here, and we're measuring from A to B. So how do we want to do that? Well, we're going to put that on hold for just a minute and just kind of do some circuit analysis on the circuit. So if this is my circuit right here and my 8-volt source is supplying current to the circuit, some of that current will go this way, some this way. So basically my 6 and my 4 ohm resistor, 6 and my 4 right here, those are in series with each other and they're in parallel with the 2. So the first thing I'm going to do is a little bit of reducing our circuit. So RT is going to be our 6 plus 4 in parallel with our 2 ohm resistor, which is 10 in parallel with 2. Okay, so that would be 1.67. And if that's the case, I sub S would be 8 volts divided by 1.67. Which is 4.8 volts. Amperes. Sorry about that. Okay, so there's my 4.8 amps. Actually, I didn't even need that, did I? Because I also know that if I have 8 volts drop across my source, then I have another 8 volts here and another 8 volts across this whole branch. So that means I've got the current this way would be 4 amps. The current this way would be 0.8 amperes. And then notice from A to B, that's actually measuring the voltage across my 6 ohm resistor. If I have 0.8 amperes, actually, let's talk about direction in a little bit. 0.8 amps times 6 volts is 4.8 volts. And let's talk direction. So my current is coming up this way, so that means that my voltage drop would be in this direction. But notice I've got A here and B here. When I have A at the top and B at the bottom, that means that I'm assuming that this is positive and this is more negative. And it's opposite of that. So E Thevenin in this case is actually negative 4.8 volts. Now that doesn't make a big difference to anything except the direction that I'm going to draw my voltage source in for my Thevenin equivalent circuit. So step 3 is to draw your Thevenin circuit. And you'll need your E Thevenin. I'm going to draw this in that upside down direction. You need your R Thevenin. And then there's A and there's B. So R Thevenin we found was 2.4 ohms. E Thevenin we found to be 4.8 volts. And again, I drew it upside down because it came out negative. And then we just put back whatever we took out originally, which was R4. So I'm just going to put back that 3 ohm R4 right here. And there's my Thevenin equivalent circuit for the circuit we were given. Notice another thing is that if we had chosen instead, let's say we wanted the Thevenin equivalent circuit for everything external to R3 instead, well, that would be a completely different circuit. And you might even want to try it out and see what you would find there.